welcome. Some of you got the joke, and that's good. I'm not getting my there. Is that better? No. Now people on the recording will actually hear me. My name is Carl Worth, and
I'm Behdad Esfahbod.
I let him say that because I can't pronounce the H in his name properly.
I didn't either.
We both work for Red Hat, and we've both been a part of the Cairo community for several years, and that's something we wanted to talk about today. Somehow some of you came to this talk. I think there's some interesting telepathy going on, which sounds like something really cool. A talk, if I were at this conference, that's the talk I'd be at. So I won't be offended if any of you get up and leave in the middle of this. But we wanted to talk, I think the first GWADEC talk about Cairo was from Owen Taylor, I don't know how many years ago. And I gave a talk at GWADEC last year. It wasn't about Cairo, it was about API design, but it was very much inspired by several of the things we learned from Cairo. So that's at least a couple of technical talks at GWADEC that have touched on Cairo. So we didn't want to do a technical talk about Cairo. We wanted to do something different today. And we wanted to talk about the Cairo community and how it's developed, how it's grown, what's been good about it. And the reason, one of the reasons I thought this would be a good topic, generally the way I always choose my topics is I figure out a question that I don't know the answer to. And then I write a proposal saying that I'll tell everyone what the answer is, and that gives me 6 months of a lot of pressure to find out the answer. So this time I was wondering, I thought that we had a really interesting community in Cairo. It's a fun place to be. It seems to be attracting people and working well, and I wondered what it was that's made it work well. And so that's one of the reasons I wanted to give this talk, is to try to figure some of that out. I don't have a lot of answers, actually, but I will be interested at the end to maybe get some feedback from you. So very, very briefly, on one technical slide only, we're going to talk about what Cairo is for anyone who isn't aware of it. Cairo is a 2D graphics library, and I've got... did I do something funny? So I wanted to briefly show what the rendering model of Cairo looks like. In Cairo, we have basically the way some drawing libraries work by you draw different objects. You might draw a line, or you might draw a polygon, or you might draw an image. And Cairo has a fundamentally different model that, if you don't wrap your head around it at first, can be confusing. But once you do, I think it's actually quite simple. First off, what you set up is a source pattern. And the source pattern is sort of the paint that you're going to work with. Although paint's a bad metaphor because a source can be translucent, where paint often isn't. So I have on the left side 4 different kinds of source patterns. The first one's a solid or uniform color. It does have translucency, as you notice. The second one's a linear gradient. We have a radial gradient. And then we have an image-based pattern, or a surface-based pattern. And as you go across, there are basically 5 fundamental, there's one fundamental drawing operation in Cairo. It's actually quite elegant that there's just one thing that you can draw. There's only one operation you can perform. It does come in 5 different flavors. And the different flavors vary based on how one argument is constructed, which is called the mask. So the basic model, it is slightly simplified, is that you take this source pattern, you intersect it with the mask, and then you blend that onto the destination, most often. You can do other things instead of blending. But so in the middle, we see 4 of the 5 basic operations. The first 2 involve a path, and so I've got a path that shows the GNOME foot. And in the first operation, I'm stroking that path. And in the second one, I'm filling it. The third line, we're actually using a text glyph, so it's basically the same kind of thing, but instead of setting up the path manually, you're actually getting vectors out of a font. And in the fourth final operation, which is called mask, we're actually using an explicit pattern again, another pattern where you've explicitly set what you want to happen in the mask. So in this case, I'm using another radial gradient, but you could put absolutely anything you want there. You could use another image as the mask. And on the right, you can see the result of, so that's stroke, fill, show glyphs, and mask. There's the fifth variation is called paint, and in the paint operation, there's effectively no mask or the infinite mask, depending on which sense you want to think of it. It just draws everywhere. Okay, so that's enough of the technical stuff. I want to talk about some of the history of Cairo and where it came from. Initially, and I'm going to dominate the talk just a little bit at the beginning here, because initially I was all it was, because there wasn't a very exciting beginning to Cairo. I was working for the University of Southern California in 2002, and I was writing a little program that drew some maps on a little handheld computer. We were using iPacs at the time. And I looked around for graphics libraries. We had a very small display, like 320 by 240, so you only get a quarter of the number of pixels you get in, say, Neo 1973 today. And I needed to pack a lot of information on there. So one of the ways I thought would be really useful to get information is to overlay with translucence and to actually use anti-aliasing to get more information per pixel. And I looked around at some of the libraries that were available, such as GTK and Qt, and I didn't see a lot of the operations I wanted to do. There were in some specialized cases, like something like non-GNOME canvas, but sort of the core APIs didn't provide a lot of what I wanted. So I said, well, let's see if I can figure this out. And I'd recently heard about the render extension. And I said, well, the render extension has this anti-alias text. Certainly, maybe it can do some anti-alias geometry as well. I looked up the protocol specification, and it had all this language about how it could do trapezoids, and I said, oh, that sounds promising. Maybe I can do that. And I tried to write a program using it, and I couldn't find any of the functionality. So it just turned out that I had recently been introduced to Keith Packard, and I asked him, I said, well, this protocol specification talks about as if it could do all these things, but I can't find any of the library for it. And he said, oh yeah, we've never written any of that. Haven't written the library, we haven't written the implementation in the X server anyway, either. He said, so by the way, do you want to write an implementation? All we need is a little trapezoid rasterizer. And so he drew me a picture that looked kind of like this. It's kind of a wacky specification of a trapezoid. You got 4 lines, effectively, instead of 4 points. But basically, the job was, given these 4 lines, find all the pixels. So we're zoomed in on the pixel grid here, and you can see the lines are positioned with sub-pixel precision. But given those pixels and those lines, compute the alpha value, how much coverage you have for each pixel. So I wrote that function, and it went into the X server. Now, the application I was targeting at this time, we can see here, and we didn't get a chance to test if this next part's going to work. We'll find out. This was the application. It's you see there's some overhead map drawn. We've got these sensors. I could talk a lot about what the experiment going on here was, but that's not today's topic. These sensors were trying to track a vehicle as it drove on this sort of oval track, and they were trying to show. So these red bars are showing where the sensors think the vehicle is, and so where they intersect is hopefully where the vehicle actually is. And they're kind of intersecting right on the road, so that's good. The experiment was working on this one carefully selected frame. And so that's what I thought. I thought, yeah, if I could draw translucent beams and they'd stack up and overlap, it might actually give some visual indication of what's actually happening here. And in the time it'd taken me to implement the trapezoid rasterization, I was out of time to finish this application. So, and I initially imagined drawing sort of an arc as these beams would sort of sweep around, and it's sort of a curved edge on the tip and all of these things. But I didn't have that. All I had was a single trapezoid. So instead, I just made sure that the beams always were longer than the screen, and that way as they swept around, you couldn't tell that there's just 2 different trapezoids being drawn there. But that program actually worked and drew some stuff. So this all predates anything of Cairo. Let's see what happens. Behdad experienced a mysterious slowdown on his laptop moments before we began our talk. And we're watching that happen, afflict us now. Okay, like I said, this had nothing to do with Cairo. So I did this, and I was able to demo the application I wanted to demo. And that was pretty successful. Except that I went back to Keith and I said, but Keith, that's not the image I wanted to draw. I wanted the beams to end before the end of the map, and I wanted to see a nice little curved edge. I mean, it was only a difference of a few pixels. It really wasn't that big a deal. But I said, I was just a little unsatisfied. There's a bit of a perfectionist in me. Okay, so here's the video clip we were trying to play. So you can see the vehicle sort of wandering around there, and the sensors are tracking it as it goes. But I was totally, like I said, I was totally unsatisfied with this result because I wanted a curved edge on the end of each beam. And I wasn't going to rest until I got that. So I said, Keith, now that I've got this trapezoid thing in the X server, what am I supposed to do? How am I supposed to draw curved things? And he said, well, it's really simple, really. All you need is a little library to take any arbitrary shape and break it up into trapezoids, and then we can render them with the X server. And the idea being, hopefully, then that the X server could take those trapezoids and render them with some video hardware that knows how to rasterize things very quickly. So in June of 2002, the demo you saw there was from April. So just a couple months later, I followed up with Keith, and he suggested maybe that the PostScript specification would be a good place to get inspiration for an API. And I agreed with him, and I said, yeah, let's go look at what it has to offer. This was the sort of the initial email that formed what later became Cairo. And I'm sure that's too small for you to read. But if you look at, we had the name XR at the time. We later changed the name to Cairo. And we had a lot of API on that first day. This was the first, well, I would say it's the first commit, but we weren't even in revision control. This was just an email that had this API. We have create and destroy for the context, which is still there, save and restore, new path, move to, line 2, close path, stroke, and fill. And that's sort of what we still use all today. There's a couple of things that disappeared. Clone, set picture, and set color all disappeared or changed into some other shape. But a lot of the core thing is there, and it was obviously just inspired, just trying to do sort of a PostScript model rendering engine. So again, that was the beginning of what was then called XR. I was the only user of it. I wasn't setting out to write any fancy library. I was just trying to finish this map display program. Now, sadly, 5 years later, I'm still trying to finish the rendering library, and I never got back to the map program. So I don't know. Maybe that's why I don't work at the University of Southern California anymore. I don't know. But I wanted to show what happened to the project without me expecting it. I went through recently, and I looked. In 2002, there were a total of 2 committers to what was then XR and then in CVS. So that was Keith Packard and myself. In 2003, we started getting a few other people. I don't know where they came from originally. Somehow, someone heard that there was some code being written. It wasn't on any like project site. This was like at keithp.com, which is a computer in his closet on his DSL that we were committing the code to. Again, hadn't talked to GNOME or anybody, but some people started using it and started contributing things. So we had 11 committers throughout 2003, 12 committers throughout 2004, and then it was around then, I should have the release dates, things actually started picking up quite a bit. We had GTK decide that it was going to start depending on Cairo, and after that we had Mozilla expressing interest, and some future versions of Firefox are now going to be rendering everything with Cairo. And quite recently, we had a big jump. In 2006, we had 54 different committers. And these aren't totals. This is during that year, we had 54 active committers. So far in 2007, we've had 44. And we'll see how it plays out. I think the total number of unique committers to Cairo right now is about 95 different people have authored. So if one of you in this room wants a chance to be the 100th author of Cairo, or if you want to be within double digits instead of triple, you got to get those patches in quick. So fire them off to us. But I've been really satisfied. It's been really fun to watch this grow, especially because, like I said, I was never trying to, initially, I wasn't trying to set out to do anything big or important. I was just writing some code, and I thought, maybe someone else can share this. Maybe someone else can also use this. Maybe I should make sure that this piece of my program is reusable. And it went on to become a lot more than I ever expected. Do you finally get to talk? I'm tired.
Okay. So it was around 2003, 2004. I just had moved to Canada and started hacking on Pango more seriously. And it was about the same time that Arn Taylor had moved from hacking on Pango to hack on Cairo. So I was in this desktop developers conference in Ottawa, and Carl was talking about Cairo. So I was there. It actually was a tutorial. And afterwards, I got to port a couple of applications to use Cairo. And GTK was just releasing the version, the 2.8, depending on Cairo. So I started reading Cairo code just for fun and profit, sending trivial simple patches to the list. Some of them are still not applied.
Yeah, sorry about that.
But around the same time, it wasn't just me. By the GTK Plus adoption of Cairo, lots of people headed to learning Cairo and finding it fun to hack. So through the years, Cairo found lots of backends, most of them experimental, but some of them seriously developed and useful. So you see, it started as an Xlib rendering library, but an image surface was added later, PostScript, XCB, which is an experimental one, Glitz, which Dave Riefman did, who's here. Later on, I think Owen did the Win32, PDF, SVG, Quartz, and the latest backend we've got is a new Quartz backend, which is a complete rewrite in 2007. So most of the smaller backends, like the DirectB, BOS, OS2, we never looked at the code. There's someone having interest to run in Cairo on BOS, and they just wrote the code thanks to the having lots of backends to look at and copy code from, and they just send this message, oh, I've got this backend, so feel free to commit. This is the, yeah, just send your SSH key. There's also a lot of language bindings for Cairo, starting from C, which is it's written in C, but all kinds of people have started adding bindings for Cairo, thanks to the binding manual that Owen wrote. You see all kinds of personal projects up to PHP, Perl, Python, Java, whatever you want. What is so slow? Okay, that was my obligatory history part. I wasn't around back at the time. So I'm going to do some, we go over the happening in the project since last year. It's been a lot different than previous year because lots of new faces showed up, lots of names that we never had heard before, neither in GNOME project nor any other projects. Most of them have a specific interest in some specific part of Cairo, and I always say Pango Cairo together, so sorry. This is a hard one. Cairo tries to be thread safe in that if you lock enough objects, if you have enough locks around enough objects, you can use Cairo from multiple threads. So we do need to do some mutex locking ourselves. But the problem is that on some systems, you have to define the mutex when initializing the library. And the code was so bad that every time we added or removed the mutex, the Win32 backend couldn't compile anymore because nobody compiled it before the release. So we wanted to fix this problem, and it was there literally for months, and nobody cared to fix. So what I did was I didn't have access to Win32 or any other exotic system. So I thought I'd just write about a possible fix and solution. So I wrote this, 100-line mail to the list. And a week later, Matthias Hasselman, who's here, I guess, sent a patch, Sent a patch, and we committed, and we're happy that we fixed it. So we made the next release, and it was more broken. So I give it another try to fix the commit, to fix the rework, and in what could have been a single huge commit in CVS, it turned out to be like 20, 30 small commits in Git, and then Carl didn't like some of them, so I had to redo it again. And I committed, and then when we wanted to add the stops for other exotic systems, we figured that it's not well documented, and we don't know how it works. So I did yet another rework and rewrite and documented it, so we were finally happy about it. It took us probably like 80 or more commits to do something as simple as some code refactoring around, but it was a lot of fun and a lot of people involved.
A really interesting thing that's happened over the last year has been primarily to work by Chris Wilson. I don't know if Chris is here this week. I'd love to meet him. He goes by Ickle in IRC, so we know him more by the name Ickle than Chris. But I don't know. It's interesting sometimes to try to figure out where people come from. 'Cause sometimes it's just an idle phrase that we throw out. Like we say, you know what would be really nice if there were more, if we did some fault injection to verify that we're actually checking all the error situations that we need to handle in Cairo, such as out of memory. In order for Cairo's error handling scheme to work, Cairo itself has to be very good about checking everything internally. This is something quite different than, say, GTK and Xlib do. GTK and Xlib take the stance that checking for every out-of-memory condition is really hard, and also perhaps in many cases there's nothing the application could do about it anyway. So the easiest thing an approach to take that you can know that you get right consistently is to just immediately exit as soon as you run out of memory. But we wanted to do something else with Cairo. We actually wanted the application to be able to recover from it if it so chose. But the difficulty of that is then verifying that you propagate out those out-of-memory situations at every level all the way back out. And it turns out there were, I don't know, something like 89 different places that we had bugs in this, because that's how that was the length of the patch series that Chris sent in. The way he generated these 89 commits was he wrote a Valgrind skin that actually exhaustively injects failures into subsequent mallocs. So it would run the Cairo test suite and insert a fault, return null from the first malloc, and then it would run it again and return null at the second malloc, and then the third, etc., until it had gone through every malloc of every program in the test suite. And he did that both on Cairo's performance test suite and Cairo's robustness test suite so just fixing errors as he went along until he got to the point where you run either of those test suites and there are no crashes anymore. All the errors, all the out-of-memory errors are handled correctly, which is a fantastic place to be, because there's basically no way to take this stance that we did that you can handle out of memory unless you test it. We saw very plainly that it was ridiculously broken, but we were really glad to have it fixed. And one of the things that made me most excited about it was that the solution is so easily reusable. It's a Valgrind skin. I don't know. And one of the reasons I want to talk about it today is I don't know what state it's in. I don't think anyone else has tried to apply it to another project yet. I don't know where it even lives.
It's on a Git repo on fdo/tilde equal, I guess.
Okay, so there is a Git repository, and if you want to find out more about that, you can certainly find us on the Cairo mailing list or something. And it's actually quite flexible. For example, Cairo depends on underlying libraries like font config and free type that don't successfully check out of memory conditions successfully, and you can selectively exclude calls coming from those libraries from getting any faults injected into them. I'm hoping that Chris will now take his techniques to those libraries, because until the underlying libraries are just as robust as Cairo, it doesn't really bias anything. But that's an exciting thing to do, and an approach that other projects could take on as well.
Oh, okay. So the story behind this one is that the Firefox people decided early on that they want to depend on Cairo for all their rendering for Firefox 3, which has been due out next month for about a year now. So one thing they found really interesting and easy was since they were moving from a non-Cairo platform to Cairo platform, they could blame every performance problem on Cairo and Pango by extension. So they have all kinds of problems with Cairo. It's slow, it's bad. And they also keep their own tree in their own copy of the Cairo tree, so we fix bugs, they don't get the fix, and all kinds of problems, including the latest problem they had was that, we profiled Firefox finally, and 15% of time is spent in malloc, and most of the calls are coming from Cairo. What's that? I said, okay, I'm not going to talk about how you can get faster by trimming that 15%, but if you really think we are doing too much malloc, okay, I take a look at it. So we are looking for a tool to easily analyze our malloc patterns. And Ekel again wrote a Valgrind scheme to count the mallocs, but it was so slow I decided to write my own tool. So I spent 2-3 days to write a tool that reported all the malloc calls from the backtrace they are coming from and the number, total size, everything. And then we just started going from the top and optimizing them away. In most of the cases, it was the case that we had a small object allocating another small object. So the fix was simply to embed the object into the other. So I fixed about 10 malloc colors, and Matthias fixed only one. His only one reduced 3 times as many mallocs that my 10 changes reduced. Yeah. So that's one way to not optimize. But the point was not that we didn't even had any data that this will make anything faster, but it was a lot of fun. So we did it.
Sometimes, yeah. Often, you know, as optimizing goes, it's important to actually profile and know that you have a real performance problem. But sometimes, even if you don't know that you have a real performance problem, if your name's showing up at the top of the list, doing something to get it down off the top is sometimes beneficial, at least from a social perspective. So that was a case where, yeah, we made something disappear from the top of Mozilla's profile, and they were happy about that.
And of course, I get a lot of blog posts, oh, you rock, you reduced the mallocs. Nobody cares, though.
They had fun doing it. Another person, we've talked about Chris Wilson, who's joined in. Another person that's joined in the Cairo community, particularly in the last year or two, is Adrian Johnson. And this is one of those amazing treasures of a person to appear for a project, because he's a domain expert. He showed up knowing a lot more about the about how PDF works than I ever have known. And every time we mention a hard problem, we just kind of say, oh yeah, someday it would be really nice if we fixed the PDF backend so that, let's say, instead of falling back and rendering a giant image as soon as we hit something that... So Cairo has a pretty rich imaging model, which I showed in that first slide. Sometimes PDF can't express everything it can, or PostScript similarly. PostScript even much more often, because PostScript doesn't even have any translucence. So right now, in the released versions of Cairo, what happens is as soon as you hit any operation that PostScript or PDF can't handle, Cairo falls back to rendering an image the size of the entire page, and then it shoves that image into the PostScript or a PDF file. So you get rather large output. And Adrian said, no, that's not acceptable. We need to fix this. And he said, gee, Carl, what's it going to take to do this? And I, just like Behdad did, just fired off a few lines saying, well, it might look like this, might start the code this way, and see what happens after that. And a couple weeks later, Adrian says, well, Carl, when are you going to commit my patch? Here it is. We've got fine-grained fallbacks, and it only falls back to the minimal image necessary to get the right result. So that's really exciting, and I still haven't committed that patch. Admittedly, he is asking for my help in fixing one little bug, but that's something that's going to be really exciting in our upcoming 1.6 release, to have fine-grained PDF fallbacks. Another thing that's happened is there's an API in Cairo called the group interface, where you can temporarily redirect rendering to an off-surface, to somewhere other than the destination. And you can do some compositing operations there, and then so you can push onto a group, and then you can pop back and blend it onto the surface again. And there's various times this is a useful thing to do. And this is another case where PDF was doing the wrong thing, and every time you push to an off-screen group, it would immediately go to an image fallback instead of actually rendering, keeping things in vectors. So you'd get early rasterization. And what happens after you did that, if you did any scaling, of course, everything would look awful. And again, the resulting file sizes were really bad. So this is something that Inkscape ran into. They've recently, as a result of a Summer of Code project, have an exporter where you can take your SVG files and export them to PDF by going through Cairo, which they're hoping will let them throw away. In fact, they may have already in CVS, or Subversion, their latest stuff. They may have thrown away their old PDF exporter in favor of using Cairo. But it turns out that the push group, pop group is a very natural thing to use when you're rendering an SVG file that has lots of little grouped objects together. And so what's happening is the PDF that was coming out of Cairo had lots of premature rasterization in it, very unsatisfactory result. And Adrian, about a week after he had the fine-grained fallback, said, "Oh, and by the way, this was just days before before I flew out to Guadalajara. By the way, here's a patch that makes it so that every time you push to a group in PDF, it maintains everything in vector form and doesn't do any of the rasterization." So that's some really exciting stuff that'll be coming along in 1.6. And again, it's maintainer. He's sort of a subsystem maintainer within Cairo for the PDF backend that appeared out of nowhere and can take small hints and do amazing things with them.
Oh, okay, this is the hard one. We have been working on this issue for the past 3 or 4 months or maybe more, and we just recently could say we fixed it. People have had problems with Cairo being slower than XFT. Mostly the embedded people, they didn't want to move away from GTK 2.6 because 2.8 and 2.10 were slow. And one of the good things they did is that they actually measured this. So we could see that the Cairo text API is slower than XFT text API, but we had no idea why. Early on, we did a lot of optimizations in Pango and all kinds of things. We could get it a lot down, but still slower than XFT. So one thing that Zan Lopez did, is here, I guess, was to, he actually got a nice tool called Xtrace and showed us the difference between the traffic that XFT sends to the server versus the Cairo traffic, and it was obvious what the problem was. Where XFT was sending like 1 or 2 bytes per glyph, we were sending 20 or 30. And it was an obvious thing to fix. It was a matter of 2-3 nights to hack on and get the exact same traffic as XFT for the glyphs. And when we got down to that level, there was one single other difference. It was that whenever we wanted to paint something to the X server, say with a solid color, the way it works is that if you want to render something in black, you create a 1 pixel by 1 pixel surface in the server, paint it black, and use that as a source to paint your object. So what we were doing was we were recreating these 1 pixel by 1 pixel surfaces all the time, and they are really small. It shouldn't show up, but it's a lot of traffic, and on a slow connection forwarded X server, it shows up, maybe. But we wanted to fix that, and we had some of the embedded people submit patches to do that. The idea was to just cache the, 16 recent ones. So when we did that, we figured that we can cause crashes in multi-threaded applications, because if you are using the cache from one thread, you may cause one of the surfaces in the cache to be evicted, and it will try to free the resource in the X server from the wrong thread, as that causes an X server error. So when we got to know the problem, it was obvious that we have the same problem with fonts too, because we cache the fonts and we may free them from any thread. So we needed a way to fix the thread that we contact the X server from. So the problem was open for a couple of months. We committed the initial patch, reverted it, made another release. But basically nobody was working on it, and all the people wanted the optimization back. So I don't know much about the X server or the Xlib, but what I knew was that all we needed was to defer the work to something that is safe. So I just wrote another 100-line email to the mailing list, said, okay, this is what we need to do. And 1 week later, Ekel came up with another patch to do that. So we committed his patch, and we were all happy. We got the optimization, we got the fix, everything, and we made another release. And it was working perfectly, except for that when it hit the Fedora testing updates, OpenOffice.org crashes on it. And it took Ekel a few days to figure out what was going on. And when he found the problem, it was obvious that it was already happening in our test suite too. But we didn't notice because we were ignoring the X errors in the test suite. So, when we know the problem, we had to make a compromise, and it took like 2-3 patches to fix it. But the whole process of 3 or 4 months of working on the issue was quite revealing of some problems we had, and we got some lessons. For example, as a result of an issue caused by this problem, we are now running the performance suite as part of our test suite too, because it's not about the performance there, but it did reveal some bugs with the Xlib issues. So we are doing that. We are trying to be pedantic about the test suite and not ignore errors anymore. And hopefully we have got this fixed.
So yeah, and that's work that, unlike the PDF stuff, that's all in the latest release, 1.4.10. So we are at a point now where the embedded people that have been using the latest Cairo versions have measured it and found that text rendering with Cairo is actually faster than rendering with XFT. So compared to a year ago, where people were doing lots of measurements where Cairo was slower, switching to Cairo meant a slowdown. In many cases, if you're measuring Cairo itself, it's actually faster. Text ends up dominating. So that was a very, very good thing. Many thanks to Chris Wilson and everyone else who contributed to that. So we ended up spending more time on the technical stuff than I wanted to. I wanted to talk about some of the lessons we've learned here. I guess Behdad wanted to talk about version control a little bit.
Okay, it's typically Carl or Keith Packard who talk about Git, but I want to do it this time because I'm not sold out. But when I started to use it, I actually liked it a lot, and I love it now. So in short, if you don't get it, you don't get it. Last night is a good example. We have been hacking on our slides since, I don't know, last night till this morning. And we didn't have any internet access in the hotel. But at least we had a local network, and each of us had his own repository, and we just commit pull from each other. We didn't even have to bother to push the changes to a server or a shared repository. Oh, and it's the right thing to do. Yeah, it's slow. So the other good thing about Git is that it's so fast and it's all local, and it's so easy to dig the history that we now use it to do minimal changes that still compile and work. So instead of having a huge patch, we may have 20, 30, 50 patches. And around the release time, Carl and I count the commits, and most of the time I'm far ahead, but around the release time, Carl pushes a lot of stuff and uses like 5 to 10 commits for the release itself. But yeah, tiny commits earn points faster. Apply now.
So another point on that, the tiny commits, I think one of the biggest things that's changed since we switched from CVS to Git is that history isn't just something we generate and forget about, or perhaps generate and say, oh, we have this nice warm fuzzy feeling that we know the history is available somewhere, but it's actually something we're using on a continual basis. Since all of the history is local and there's no network access involved, there's so little cost to actually exploring the history that we do it all the time. We find out what went on. And one of the ways we do this very regularly is with the Git bisect tool. Every time a bug shows up on our development branch, I know that the stable branch is always passing the test suite. We never commit anything to the stable branch that doesn't pass this test suite. So as soon as a bug shows up, all I have to say is I say git bisect bad experimental branch, and I can say git bisect good stable, and then it just starts binary searching the history between those two branches and drives me right down to the one commit. And says this was the first bad commit. And when that commit is 10 or 100 times shorter than the average commit size that we had in CVS. It makes it a lot easier to say, oh, exactly, that's a 5-line commit. I know what the bug is. And when git bisect drills down to a 500-line commit, and this is one of the things that actually happened right when we switched to Git. We still had a lot of bugs that had been recently committed in CVS. So Keith Packard committed a huge rework to the font subsystem, and I think there were 6 or 7 big bad bugs that we ended up tracing down to it. And it was this miserable feeling every time you started git bisecting. You said, oh no, I know exactly where this is going. It's going to that same 500-line commit that had all these bugs in it, and we're hopeless to find out. That same commit now, if we did a rework like that, it'd be 40 or 50 independent commits, and you'd have this one, you'd be told which one of those actually introduced the bug. So some of the other lessons in terms of community building is that the Cairo project's been pretty free with commit access. It's kind of funny to even talk about commit access because within a Git world where the revision control is distributed, everyone in the world has commit access. Everyone has full access to all the benefits of it being able to create commits. So you don't have to, one of the things, you don't even have to ask for anything with Git. You just start using it and generating commits. You get all the benefits up front. But even when we were using CVS, and even still with the central repository that we have for Cairo, as soon as anyone commits a patch that actually looks reasonable and more than sort of a trivial one-line build change for some obscure proprietary operating system, as long as someone's like implemented something interesting, more than like 5 or 10 lines of code, I'll almost always follow up with, they'll say, oh no, will you commit this patch for me? And I always follow up with, well, you know what I'd really like is if you would just push it yourself. It saves me work. I don't even have to touch their patch. I just have to review it and say, please, here, give me an SSH key, and then you can do all this work for yourself. And I think it's proved beneficial. We don't wait a long time or make people go through a long, hard process. And my feeling is that, you know, showing someone the respect to say, yeah, I'm going to trust you I'm going to give you this privilege, use it wisely. People we've never had any problems with people committing random lousy code. They'll sometimes generate a lot of random lousy code, but they'll always throw it at us on the mailing list and say, yeah, is this okay? People know if they're generating solid stuff or not, and they're pretty good. And so I think showing them that trust actually pays big dividends, that we don't have to beg for new maintainers and new contributors. They seem to keep coming all the time, and they stick around. It's not just one patch. They get the one patch, and if we respond quickly, I'm sorry, Behdad, that you have a 3-year-old patch that I haven't applied yet. But you know what? It's your fault now because you can apply it. So
that's true.
But anyway, I'll let Behdad take this next point.
Okay, so around last summer, I guess I started becoming a Cairo maintainer, and the story behind that is that Carl was busy with other stuff, and we had a critical bug in the X backend, and I found the fix and committed, and I really wanted to get it out because I was getting multiple bug reports in Fedora. So I said, Carl, do you mind if I make 1.4.4? He said, oh, go ahead, and something like that. And after that, I started to care about all parts of the project and follow the bug reports, go hunt for easy fixes in Bugzilla, or respond to patches sent to the mailing list. But after a while, it became obvious that I can't spend time fixing all the known bugs. So what I started doing when I had any ideas about the fix, I just, instead of going on and scratching my head about the fix, I just started writing down my ideas about the fix into a solid write-up and set it to the list. So instead of spending 2-3 nights a week hacking, I just spent 2-3 hours writing a 100-line email. And when you give people something interesting to read, they actually want to fix it right away. So every time that I did that, it took less than a week to get an actual fix, which wasn't a small fix at all. Thanks to Matthias, Ikel, Adrian, all of them. So that has been one of the workflows for me in Cairo. Just see what the current open bug is, think about it for a couple of hours, write to the list, and hope for the best. It actually works really good, except for API proposals. Nobody likes new API because if you can't show that it's really necessary, nobody is interested in implementing that. So I need to find a new way to trick people into doing that.
This has played out really well, and I think we've been learning. Behdad and I together have been learning what our role can be as a maintainer. It's not to generate the majority of the code. It's to generate other people that are generating the majority of the code. And I didn't put that slide together, but if you look at the ratios of the number, it's interesting. I looked at the over the last sort of a 2-month period this year and a 2-month period last year. Under both of the same time periods, I generated 96 commits or something like that. But a year ago, while I generated 96, other people had generated 48 or something like that. And this year, when I generated something around 96 again, there was something like 280 generated by other people. So the ratio of the code that I've been producing, generating to the project, has gone way down, even if the absolute amount hasn't changed at all. And I think that's really essential in terms of scaling the project and letting the community grow, is finding ways that we can magnify and multiply our work as a maintainer. And Behdad, as he described, has been an expert. You heard him mention 3 or 4 times in today's talk where he was able to describe a solution and people implemented it. And that's been very successful. More than describing a bug or describing a wanted feature, not describing the bug, but actually describing what the solution is. And that's something a maintainer can do. We have over 500 people on the Cairo mailing list. Not all of them have the expertise to go in and figure out what the problem is. But if you can say to them, this is a known problem, this is what would fix it, they're very eager and willing to help make it better. So another responsibility of the maintainer is to stay on top of things, keeping people interested. It's really easy to get a feel for sort of these ebbs and flows of the Cairo community when nothing's going on, when there hasn't been any traffic on the mailing list, when patches have come by and we haven't responded to them, and you can just feel the energy level of the project going away. So it's something that it's important for the maintainer to stay on top of. But again, you don't have to do all the work. And so another trick that I've learned recently is tricking other people into answering a lot of the questions. Daniel Amelang is someone who's come along and done some fantastic work for Cairo in the last 1 or 2 years, and is right now working on a re-implementation of our image backend that should speed it up quite significantly. He has now taken upon himself the role of answering sort of newbie questions that come across on the mailing list. So maybe I will see a question and say, okay, that's been answered so many times I don't really feel like answering it. And Daniel will see it and say, oh, look, that question went a day and a half without anyone replying. I better reply to it. And at first he was really unsure of himself. He's like, I'm new to Cairo. I don't know that I know the answers. But just instilling him with a little confidence and encouraging him, saying, yeah, I really appreciate you answering that question. That really helped me. And what the other thing I've been able to do is just watch Daniel's answers, and 3 or 4 go by and they're fine, and then a 5th one comes and it's maybe correct, but it misses some details. I'm able to answer. That's when I step in and follow up with 100 lines of email explaining some subtle issue. That if someone like Daniel has been around for a year and he didn't pick up on this, then certainly other people need to do it, and it's worth my time then to step in and do some more. And again, so multiplying my effort by taking advantage of other people. So again, those are some of the things. I don't know how well I captured why we love Cairo, but I think for me it's been a heck of a lot of fun to work on, and I hope that all of you that came here have that similar association with the Cairo project, that it's a fun thing to do, it's fun to code on, it's fun to use. We've always had as one of our primary API design goals that it be really easy to use and that it just be a real joy. And that's something that I've enjoyed more than anything else, is when we get a random first-time post on the mailing list and they say, hey, I just wanted to say I really like using Cairo. I've been using it for a week now, and it's really fun. I really like this. And I think that's great. That makes my day every time someone says that. And I don't know. It's just really fun. And I've been trying to figure out what it is that's unique about Cairo, or maybe it's not unique. Maybe every free software project is this fun and enjoyable, and this is just the one I'm in. I guess one of the things I wanted to open up to, and we are out of time, and it's sort of time for questions. In addition to questions, I'd love to have comments from anyone here on what's gotten you involved in Cairo. Why have you stuck with it? Maybe we've got Pippin and Tor and other people who have been around the project, and for years. What is it that originally drew you to Cairo, and why have you stuck with it, and what have you enjoyed? I'd love to hear any comments on that. Anything else? Thank you.
Let's go. Hey.
I started using it because I needed something rich in a tree view in my project, and it became trivially easy to create something which scaled nicely, which rendered nicely, which looked beautiful, and was nice and fast to render. So I just picked up Cairo, started working with it. It's absolutely beautiful. It's a perfect API to do exactly what we want.
There's lots of words. We can do that discussion.
We didn't pay him.
Thank you, Carl. Other questions, comments?
Any other questions?
Why Cairo? I mean, the name.
Oh, yeah, I should have. So the original name, like I said in one of the slides, was XR, which was sort of a horrible non-name. What I thought I was inventing at the time was a little library to sit inside the X system. It was going to be an X library. Basically, I was saying there's the X render library, which is functional, but really, really hard to use. So this will just be one layer above that. And so we grabbed a randomly related name from XRender to XR. That's about all we did. We just sort of chopped off a couple of characters and said, you know, it's XRender but simplified, I think was maybe the idea. And so it was going to be easy to use. But if you look back at that chart, it was just a couple years. After the first year, we added an image backend, and then we added a PostScript backend, and we said, wait a second, this isn't an X library anymore. It's doing a lot of things. And that big capital X at the beginning of its name could really throw people off, especially when we started contemplating a port to Win32 and Quartz. Suddenly, that X could really confuse people. So we needed a different name. I had been thinking about light and illumination as sources for names. But as I did so, every interesting word that has anything to do with light, whether it's or color, or pigment, or luminosity, or all these sort of interesting words and roots had all been taken by dozens of other projects. I couldn't come up with any interesting name in the field of light, and because I thought light was a good thing, it was cheerful, and so the one I finally came up with was an Italian word, chiaro, which means light. You might have had a humanities class in college, and you learned about chiaroscuro. For example. And so I thought maybe there's something we could do with the word chiaro. And when I looked at it, I saw the CHI that it starts with is the Greek letter chi. And it ends, well, with RO, and I was imagining, well, if you sort of misspelled it, you could have the Greek letter rho. And then I looked at, wait, we've got the letters XR, and X looks a lot like chi, and R doesn't look anything like rho, but it's actually pronounced the same as rho. Maybe we could do something like that. But I was still stuck on the word. I was still stuck on the word chiaro, and I couldn't get past that. But I told this idea to Keith, and I said, I'm trying to do something with the letters chi and rho. Is there anything you can think of that would make a name? And yeah, Keith's like, Carl, do you hear yourself here? And so we thought we were really clever, and Keith sent out this announcement of the name change and tied it into, Egypt, which was the birthplace of writing. We've got all these, Greek and connections, and and the Latin as well, the Italian as well. And so we thought we were really clever about that. And as soon as we posted that, we got a whole bunch of people replying saying, wait, wasn't Cairo the name of some Windows thing? And we're like, oh, we never heard of that. And they're like, some project or something. And anyway, I don't know if it was a database thing or something, but it had been an internal code name for a project at Microsoft, but one of those internal code names that gets talked about in the press a bunch and things like that. And then, and then it was a few years before Windows XP came out. Now, if you look at the letters chi and rho, they look a lot like the letters X and P. So I don't know, but I thought we were clever, but maybe we weren't the first to come up with that joke. But if nothing else, we went the right direction with it, because XR was a lousy name and Cairo is great, but XP is a lousy name again. So thank you for the question.
So we have time for just one last question.
Well, I had a comment about my involvement in Cairo. It started out that I don't quite remember what I started doing, but I needed to do some custom widgets. And kind of stumbled across Cairo, and it was able to kind of hack things into working the way I needed them to work and create some custom GTK widgets. And Cairo was very, very slow. But kind of I got encouraged by Carl and posting screenshots on the IRC channel and got encouragement. It's like, this is nice, this is nifty, and yeah, and it's nice to get feedback on the prototypes you're hacking on, and eventually things started working for me, and I kind of, created a small test suite of images and things, and it got a commit access very, very fast. So it's like, what? I got a free desktop account? What's this? Got a bit scared, but it's like, okay, I'll continue. And I made a decision quite early that I did not want to get involved in the internals of Cairo. But I wanted to use Cairo, so I was probably one of the persons using it rather extensively before it was stable. So I have heaps of code that no longer compiles with the Git version of Cairo. But my kind of experience of the involvement in Cairo is that it does a lot of things very, very right. When it comes to API design and encouragement of people and how you let people kind of start stepping deeply into the project very fast. So I've been somehow trying to copy that in Gaggle as well. So kind of trying to steal your methods.
Please,
and
that's why we're here and talking about it. So thank you. Very encouraging.
So already before you start talking about it in conferences, I've been trying to copy you in some ways.
All right.
Okay, thank you. I think it's time. It's 5 o'clock.
All right. Well, if you have other questions, you can find us at chirographics.org or in the halls. Thank you.